Hey everyone, welcome to my RailsConf talk called Frontendless Rails Frontend. My name is Vladimir and I'm working for the company called Evil Martians as a backend engineer, at least from the legal point of view. And nowadays, I'm mostly doing Ruby and a bit of Golang. And I'm not dealing with the front end at work at all. Because, web development today has this clear separation of backend and front-end engineers. Everyone does its job and does it well. But that's what we have today, most of you, I think. Maybe 5 or even 10 years ago, when I started working on Ruby on Rails projects, I've been doing everything: HTML, Ruby, JavaScript, or actually CoffeeScript. I was able to build a product alone. I didn't need anyone else. I miss that times a little bit. So today, I'd like to raise and try to answer the following question. Could Rails full stack development be a thing in 2020s? And let's start with another question. What is full stack, by the way? What is it? One definition is that there is a single person who can do everything. And I doubt it's a correct definition for full stack development. Instead, I'd like to say that full stack development is when you develop within a single ecosystem. And in our case, such ecosystem is Rails. So let's take a quick look at the past and remind us how our ecosystem looked like when we were building Rails applications without needing to learn front-end frameworks and all that modern stuff. And also what happened to that way of building web applications. First of all, the core principle of Rails full stack development is HTML over the wire. Server is the only source of truth. Server is responsible for what end users see. So power to the server. That's how we can call this way of building web applications. So let's take a look at what tools did we use to build the front-end part of our apps. First of all, we had HTML preprocessors to make it easy to write HTML, and also Ruby helpers to craft HTML using Ruby code. Do you remember helpers? Something like this. Can you figure out what's going on here? I don't. I can't. Because, well, it's like, I don't understand what's written here. Hopefully, we no longer write such things nowadays. At least we can not do that. Then we added a bit of interaction by writing some JavaScript, or more precisely CoffeeScript, because it was a kind of JavaScript for Rubysts. Also, we usually used jQuery and some plugins, for example, jQuery, UJS, and obtrusive JavaScript, which made it simple to turn links and forms into asynchronous communication tools, like performing AJAX requests instead of reloading pages. And we also were able to execute JavaScript in response, like it was some kind of magic that Rails provided. Then we also have turbolinks, but no one knew how to use them properly, except from probably Basecamp. I don't know. We used Sass to manage styles because, again, it was much more Ruby friendly than pure CSS. And finally, we used Bootstrap to make all websites look alike. We deal with dependencies by installing gems using our good old bundler, or simply putting scripts into the vendor assets folder. And the top of this iceberg, we had asset pipeline, and more precisely, a sprockets library to take care of all this stuff, to build them together, to optimize them, to minimize or whatever. And those days, sprockets and asset pipeline were the best for this job among all web frameworks, not only Ruby frameworks. But things have changed. JavaScript awoke, and the evolution began. First, npm appeared and later yarn, and they solved the problem of managing dependencies. Then JavaScript, actually its standard ECMAScript, evolved to its 6th, 7th version, whatever it's called right now, and made CoffeeScript useless. Webpack brought assets compilation to the next level, and Post CSS and variety of tools built on top of it changed the way we write CSS, made it more powerful. After that, front-end frameworks appeared, and React won the battle among them. It's like #1 even today. Finally, most applications turned into single-paged applications, leaving only single responsibility for Rails, providing APIs. That's where we are today. We have separate teams, bigger teams, larger development costs, both in terms of time and money. That's something we would like to change, bringing back our Rails comfort zone. And the question is whether it's possible at all. Of course, it is, because we have some examples. Let's say GitHub and Basecamp. They're all following classic Rails way for many years. But you may say that those two are too old and too big to migrate to the modern front-end stack. They're just too expensive for them. Okay, I get it. But what about something that was just released about a year ago? Hey, use Rails as a core of its stack, and just a couple of few things to build the modern client-side experience. And this new magic, which is called Hotwire, brings HTML over-the-wire approach to the next level. But I'm not going to talk about Hotwire today, because we have 3 or maybe 4 talks dedicated to it in the program, and even 1 workshop. So instead, I wrote a blog post which you can check later. So if you want to know what I think about Hotwire. So let's go to the main part of the talk, where I want to show how HTML over-the-wire approach could help over the modern front-end technologies, what we can put on the scale on the both sides. And let's start with the core principles. Who's responsible for rendering UI, server or client? We can't say that one or another approach is better on its own. These are just 2 ways of doing the same thing, and they're equally good. Then we have single-page applications on the right. And that's how most front-end-based applications are built. How can we counter this? Well, turbolinks, or how we call them today, TurboDrive, is the answer to this. So let's recall what turbolinks or TurboDrive is. So TurboDrive allows to convert any HTML-based application into a single-page application by doing a simple trick. It intercepts navigation, like links clicking and form submission. And instead of reloading the page, it performs AJAX requests and replaces the body with the response. But just the body of the page, no scripts, no styles, nothing is reloaded for every navigation event, which makes loading pages faster. And it also keeps track of its own cache to make the perceived performance even better for the end user. TurboFrames is a new thing, is a new addition to the TurboLinks ecosystem, so to Hotwire. And it could be described as a TurboLinks for the page fragments or frames. So instead of reloading the whole page, you can reload a part of it. Or you can lazy load it when you load the page initially. So this way you can speed up the first rendering. Let's take a look at the example of using TurboFrames. Here we can see a to-do list app with items and ability to mark them as completed or delete them. And it's built with TurboFrames with no JavaScript. Let's take a look at the code. So we have our good old controllers But the only difference here that we render partials instead of templates. And at the template side, we wrap the contents with a special TurboFrame tag with a unique identifier, which TurboFrame JavaScript used to replace the contents of the element currently being on the page, or remove it completely if the contents of TurboFrame are empty. And that's it. Just a couple of minor changes to our code, and we can write interactive applications with no JavaScript. Okay, what's next? On the front-end side, we have frameworks, and they bring a lot of stuff: interactivity, reactivity, architecture patterns and concepts and conventions, all that stuff. But when we got only HTML, and when we use HTML first approach, we can only use JavaScript sprinkles to kind of vitalize our HTML. Like, for example, already mentioned unobtrusive JavaScript. But it's very simple and it provides limited functionality. We need something else. And we have. And its name is Stimulus. So let's talk about Stimulus.js a little bit and why it's a good companion for Rails development. Again, let's take a look at the example. So we have hideable banners in the application showing some tips to our users, and the user can close them by clicking on the corresponding button. So that's the whole functionality. 10 years ago, we would write it with probably jQuery, and we had to deal with all the actually unrelated stuff: events, CSS classes, other libraries like TurboLinks and jQuery UJS to make sure that these buttons are always activated. That was too error prone, too unreadable. So everyone remembers this jQuery spaghetti, so-called code. With Stimulus, we only care about what matters. Our JS code is very concise. We just need one function which implement the removal of the element. And everything else is controlled by the HTML. We use data attributes to activate these actions, the stimuli. So the main benefit of Stimulus is the usage of the modern browser APIs, Mutation Observer API, which eliminates page tracking, changes tracking completely, like we did with jQuery and TurboLinks, for example. So one benefit of Stimulus is that it plays well with Turbo, because you don't need to care about any hacks to track loading, reloading, or whatever. But Stimulus allows you to attach a behavior to an HTML element, turn it into so-called component. But you still need to implement the behavior yourself in JavaScript. You have to write a controller. And it's not always just a few lines of code like in the example I already showed. Imagine building something more complex like a date picker or search autocomplete input. How to build such complex components? Well, we can write them from scratch in JavaScript, and that would turn us into JavaScript developers. Or we can borrow them from some real framework. So, I mean, we can take React, Vue, Svelte, or whatever, and wrap them using Stimulus just in place, locally, isolated. And that's how I did for one of the projects where I actually started using Stimulus, and where I needed some interactive forms with some interactive fields. And I chose to use Vue framework for that, and Stimulus to control the mounting of Vue components into the HTML. So servers still responsible for rendering and crafting HTML. We still use Rails form helpers and everything we used before. We only add data attributes, add our controllers to the specified fields to activate them. And ViewComponent, in this case, is isolated. We do not bring any state management or whatever to our client-side code. It's simple as that. Stimulus just helps us to manage external components lifecycle. You can find the complete example in the open source demo project we published specifically to demonstrate this approach. And more examples could be found by following the links on the slide. I'm not going to announce them here. But let's take a quick quick break, because I think I just flew away for a minute, and it's too much JavaScript, right? Let's go back to HTML and Ruby and our scale. So next thing is reactivity. Let's define reactivity as an ability of the application to instantly react on the various events, both internal from a user and external from the system as a whole. In other words, like an example, users don't need to hit the reload button to see the actual state of the data. How can we do this without keeping the state on the client? Everything is on the server, right? Well, we can push changes to the clients through WebSockets. And that's where we can introduce kind of an evolution of HTML over the wire approach, HTML over WebSocket. And we can't help but mention Phoenix Live View here. This library popularized HTML over WebSocket and inspired others to bring something similar. And I want to spend a lot of time explaining how Live View works. I put the main ideas on the slide, so feel free to check them later. Let's move right to the projects inspired by it. And in the Ruby world and the Rails world, such project is StimulusReflex. Technically, StimulusReflex is a bit older than Live View, and its core part, Cable Ready, has been around for more than 3 years. But only after Live View appeared and all that hype around it, StimulusReflex got a kind of a push into their development. But let's start first with Cable Ready. What is it and why does it matter? So Cable Ready is a small single-purpose library. It helps to send HTML or DOM modification instructions from server to browsers to clients, like remote DOM manipulation controlled by the server. It uses action cables that transport and Morph DOM library on the client side to update HTML as fast as possible. Let's take a look at the example. So again, our to-do list, our items, and we want to delete them. At the HTML part of the feature, we don't need to change anything. We still use our remote call by clicking to the button. And the controller, we have some changes. We do not return any HTML in response, but instead we broadcast a remove command to the corresponding stream with a specified selector corresponding to the current item. This command could be expressed as a jQuery spell we used 10 years ago, though actually no jQuery required, no JavaScript required to perform this. Everything is done on Cable Ready. And it's not only a remove is possible, but other 30-something commands are also available. So you can do pretty much anything on your client machines from server. Let's go to StimulusReflex. It consists of 2 parts. Reflexes, which describe how to handle user actions, and Cable Ready to deliver HTML and commands and update DOM. The whole architecture of StimulusReflex is kind of complicated, so I suggest taking a look at the example instead. Yeah, again, our example is still the same, but now it's updated in real time for all users. It's reactive. So let's take a look at the HTML we have. We only need to add DataReflex attributes, which looks very similar to what we did with Stimulus, right? And it's not a coincidence because, well, as the title said, StimulusReflex uses stimulus under the hood to activate reflexes. To make this reflex attributes actionable, we need to write a class. In our case, it's listReflex, and implement the corresponding methods. Each method could do multiple things. First of all, we can use cable-ready, as we did before, and we could respond to this particular user, to the current user, with a custom modification command. In our case, we show the flash notification, which is done by broadcasting an HTML partial with a selector to replace the contents. So it's like replacing the contents of the flash container. What I like most about StimulusReflex is that it's mature, stable, and well-documented software. And it has a very welcoming community. So it's a pleasure to work with it and with the people behind it. And of course, it works with any cable. That's another reason why I like it. So StimulusReflex is not the only one who follows HTML over the wire ideology. I also have a couple more projects, at least. First one is Motion. Motion is, like in my opinion, is much more inspired by LiveView. It provides one-to-one correspondence between server-side component and a DOM element. And it's quite interesting project, but it's still evolving. So follow it to see where it will go. TurboFrames, yeah, again, from Hotwire. So I'm talking about Hotwire a little bit. So TurboFrames actually more like cable ready, but just with 5 actions, not 30. I think its killer feature is zero JavaScript to start using it, unlike cable ready or StimulusReflex, which requires some setup at least. So in order to start using TurboFrames, all you need is to add a specific element using helper, for example, on the page to subscribe to the stream. And then in your controller or whatever you want, you send a similar DOM modification command, append, replace, remove, or whatever. So again, like cable ready, but in a Rails way. So we can see that serving HTML over the wire or over the socket can do the trick. But now we have another problem. We have a lot of HTML, a lot of partials for all the different cases. We need to keep them organized. How to do that? Remember, in front-end frameworks, we had architecture, patterns, conventions, whatever. Do we have them for keeping HTML templates? I'm not sure. Maybe we should get some inspiration from front-end frameworks. And we Martians tried this approach a few years ago. Our evil front methodology demonstrated a way to keep templates under control. And it was inspired by one of the main React principles. Think in components. Components is the answer. And today we have them for Rails applications. We have ViewComponents. So what does this mean? What are the ViewComponents? I'm going to talk about a particular implementation, a ViewComponent gem by GitHub. And let me show you an example of how we can use it. Okay. So component consists of several parts. First one is a class representing necessary logic. It could be seen as a mix of presenter or helper or decorator or facet pattern or whatever page object pattern. Anyway, it's a Ruby class that contains all the logic you need to draw a template. So then we have a template, and here is how we can use it in other pure HTML templates. We just render the component, provide the data for it. It's kind of isolated from the main rendering context. And it's reusable because it's just Ruby class. So we can use inheritance, for example. We can test it in isolation as a Ruby class again. It makes working with HTML a bit different and more, I think, productive, more robust, because you can catch errors early using tests and using previews. That's one of the features I really like about view components, because you can develop them in isolation completely. So preview is like for mailers preview, built on top of the same Rails functionality, but it makes developing front end of the application very different from what we have for HTML templates. Another cool feature of view component is that it allows you to keep all the related stuff together. So we can put not only Ruby logic and HTML representation into the same folder, but also styles and JavaScript needed to activate this controller, to use this controller. And we can go further. We can actually put reflexes, stimulus controllers, previews right into the same folder, which is not possible out of the box, but we can extend ViewComponent to do that. We can also get rid of this repeated initializers and add readers. And I prefer this way of keeping view components, and I extracted all my extensions, and some developer chose to gem called ViewComponent contrib. Feel free to check it. It provides some hacks to make writing view components and keeping them a bit more convenient than the out-of-the-box approach we have. And ViewComponent is not the only one library which solved this problem, which provide view components approach to Rails. We have more libraries which you can check and try. Don't forget about something. So we compared interactivity, like organization, architecture, and all this stuff, but we completely forgot about CSS. Another power of front-end frameworks is that they allowed us to use such cool techniques as CSS and JS. And we have post-CSS, which help us to be more productive writing styles. But what can we do at our HTML site? What do we have to offer? First of all, as before, we have CSS frameworks. Like we still have Bootstrap, you can use it, but there are plenty of other options today, and I would like to pay attention to 3 of them, at least those which I used in production. I really like them. So first one is Bulma. Bulma. I don't know how to pronounce it correctly, sorry. So it's CSS only and mobile first framework, which I already used and I already demonstrated when we talked about Stimulus and Vue. Actually, this example used Bulma, and it's pretty cool because you can add a corresponding Vue components library, which Vue, not Vue, called Vueify, and make this components you can see in this video. Tailwind CSS, I don't know if there person haven't heard about this framework. It's like #1 today for ready-made CSS frameworks, but it has a different idea. It's a utility first, so no components out of the box. There is a Tailwind UI library for that, actually, but originally it just provides you with some classes to write this kind of styles on your own. And it's really cool for fast prototyping, and it helps you to build, to generate optimized builds with some built-in integrations. So I really like Tailwind's playground functionality. So you can really quickly build some markup right in the browser and then just copy styles to a project. And finally, what we have, what I mentioned, Shoelace. Shoelace is a little bit different story. It's a library of web components focused on customizability and accessibility. But web component is like CSS and JavaScript all together, and it provides some typical elements like alerts, forms, buttons, drop downs, whatever. You can just use a custom tag to activate them. It's very simple, it's very powerful, and it's very good for building, for example, admin dashboards and something like this, some internal stuff. But again, CSS frameworks are cool, they always were cool, but what if I want to write my own styles? How to keep them separated or isolated? We need something to deal with it. So we don't have CSS in JS, in Ruby, in Rails. But we can make post CSS work for us. Why not? And it plays really well with ViewComponent, I already mentioned. Let me show you how I glue them together. So let's say we have an example component, flash alert, and we have a CSS and JS for it, and HTML. In the CSS file, we write some classes, but we do not prefix them with like flash alert container, flash alert body, whatever. We do not care about namespacing, about isolation. Post CSS will care about it, and I'll show you in a minute how. In our HTML template, we use a specific helper class for container or body, which resolve this internal name to the global name, which is going to be unique due to our convention. The resulting HTML is as follows. So you see that instead of container and body classes, we have C/alert container and C/alert body. How we did this? We added post CSS modules plugin and configured it to replace classes within front-end components folder with the same names but prefixed with a C and current path transformed a little bit for uniqueness. And similarly, at the Ruby side, we just extended our application view component with a class form method, which does pretty much the same. So convention over configuration, and we solve the problem of isolating styles in our Rails app using components and some bit of post CSS magic. So I don't have anything to put on the scale. So let's talk about what we ended up. We reached the end of the talk, actually. I hope I was able to demonstrate that HTML first approach could be competitive. It makes sense to use it in some cases. Frontendless way exists, and you can follow it today. I'm already following. I'm using it in production and my own projects. And for internal tools and typical CRUD applications, admin dashboards, that's the way to go. Be productive and do not depend on other teams, other engineers, front-end engineers, when it's not necessary. You don't need a front-end to build yet another form or admin or list or whatever. You can build them using Rails and these tools I mentioned and made them cool, made them interactive. And we're just in the very beginning of this new era. It's kind of a renaissance of Rails full stack development, probably. So stay tuned, join the resistance, and thank you for your attention.